Okay, so in our first video lesson for Unit 3, we're going to look at two topics that should be fairly familiar. We're going to start by looking at linear and then nonlinear relationships. And then we're going to use what we've learned about linear relationships to solve some problems. So as you may recall from class, the most important thing to know is that linear relationships, okay, the most important thing about them is that they have a constant, right, meaning always the same, rate of change. Okay? And I'm going to introduce a new symbol here that we probably haven't seen before. But this is how we're always going to calculate change of rate, or rate of change. Okay, so the rate of change is always going to be the change in the output, right? So the change in the f of x's divided by, we use this triangle to represent change, divided by the change in x, okay? So that's a formula to keep in mind, and it works for any kind of function. But for a linear function, it's going to be especially important because it's always going to be the same, right? It is a constant rate of change. So what we're asked to do here is we're going to decide if each relationship is linear. Well, the way that we're going to do that, another way of saying this is, does it have a constant rate of change? And if it is, we're going to find that rate of change. And if it's not, we're going to say why not. So here, right, as I look at this, I see my x's going up by 2, right? And, when my x's are going up by 2, I should look and see what's happening to my outputs, to my f of x's, or my y's. Well, here, they're going what? What's the change from 15 to 12? Well, that's a change of -3, going down by 3, going down by 3, and going down by 3. Okay, so yeah, this one definitely has a constant rate of change, so it's linear, okay? So the change in my outputs divided by the change in my inputs, let's see, we're going down 3 in my outputs and up 2 in my inputs. So here's the rate of change. It's negative here because the outputs are going down. And then if I wanted to, I could reduce this and say, dividing by 2, say that every time x goes up by 1, the outputs are going to go down by 1.5. Okay? So now we're going to take a look at another one, and you should see pretty quickly that my x's are increasing by 1. To get from 1 to 2, that's adding 1. 2 to 3, adding another one. 3 to 4, adding another one. But my y's, on the other hand, don't follow such a nice pattern, right? They go up by 2. Then from 15 to 18, that's going to be plus 3. And from 18 to 22, right, that's going to require me to add 4. So there is a pattern here, right? Going up by 2, then 3, then 4, and probably by 5, and 6, and 7. But it's not constant, right? What I'm changing by is changing every single time. Okay, so this is not linear. Okay? And the reason, right, as I said, is because it does not have a constant rate of change. It's going up by a different amount each time. Now, this one here, you may look and say, wow, this one's all over the place, right? X goes up by 2, then x goes up by 1, and then it goes up by 3. So you may start to think, wait a second, this can't have a constant rate of change. But let's look more carefully. How far is it from 10 to 18? Well, that means we're going up 8, right? From 18 to 22, up 4. And from 22 to 34, we're going up 12. So you may think this is a problem, right? Because it's going up by different amounts each time. But let's check our formula. We're going to do our change in outputs divided by the change in inputs. So the outputs, right, they are 8 in output to 2 in input, right? 4 in output to 1 in input, and 12 in output to 3 in input. Now you may say, wait a sec, these are all different. But if you go up 8 for every 2, that's the same as going up 4 for every 1. If you go up 12 for every 3, that's the same as going 4 for every 1, right? If I do 8 divided by 2, I get 4 over 1. If I get 12 over 3, I also get 4 over 1, right? Dividing by 3 here. And, so clearly these rates of change are all equal, okay? So the relationship has to be linear. All right, so we should be able to look at a table and decide if that relationship is linear pretty easily. Let me clear all this out to give us space to work for the second part here. Oop, wrong color. There we go. Okay, so now we have to take a table like these guys here. I'm just gonna, actually I'll leave it right there. I was gonna move it, but we'll just leave it there. Okay, so we're gonna use the fact that we know that a linear relationship has a constant rate of change to continue this pattern here, right? And identify the value of R that's going to make our relationship linear. Okay, so just give me one moment here. Okay. So as I look at this, right, I need to find a rate of change. So, well, our x's are going up by 2. Oops, I need to change colors here. Our x's are going up by 2 in this case, from 2 to 4, right? Which to me tells me that I can also find the change in y's. And they're going down by 6, right? So as I think about that, right, and now I'm saying, oh, wait a sec, I have to go from 4 to 8. How far is that? Well, think about what we know about ratios. If I'm going down 6 every 2, well, what if I have to go 4? Oop. Well, what's going to happen, right? How do I get from 2 to 4? Well, that's times 2, right? Same thing here. Go from 6, I'm going to do times 2, and instead of going down just 6, I'm going to go down 12, right? So 24, if I take away 12, right, this is the same ratio here. 6 to 2 is the same as 12 to 4. That's going to give me an R that's equal to, let's see, 24 minus 12 gives me 12, okay? Now, another way that we could have done that, let me just show you this quickly. Oop. Let's take the same table here, x and g of x. Yeah, let's clear some of that out. Let's try that again. X and g of x, okay? Well, let's think about what would happen if we filled in some of these other numbers. So 2 to 4, I'm sorry, 2 to 30. 4 is going to go to, let's see, 4 is going to go to 24. Well, if we think about it, right, if every 2 we go down 6, this would be 18. Well, let's do that one more time. 8 is going to go to 12, okay? Let's see if we can use a similar technique to work through this next one here. So here, right, I don't know this middle value, but I know that 2 to 8, right, is plus 6. So when the x's go up by 6, what happens to our y's, our outputs? Well, 12 to 32 is plus 30, right? So that means that the outputs go up by 30 as the inputs go up by 6, okay? Another way of thinking about this is that it's 5 to 1, right? I'm just dividing by 6 here. All right, so this is kind of a unit rate idea. Okay, so this is our change in outputs, our change in g of x, divided by our change in inputs. Right? So if our inputs go up by 1, our outputs are going to go up by 5. But what if our inputs go up by 2? Right, from 2 to 4, what's going to happen to our outputs? Well, another way of writing 5 to 1 is writing 10 to 2, right? 5 times 2 is 10. 1 times 2 is 2. So if our inputs go up by 2, our outputs have to go up by 10, making the R in this case equal to 12 plus 10, which is 22. Right? So again, this relies on the idea that 30 to 6 is the same as 10 to 2. And also, in part, that it's the same as 5 to 1. Okay, so our last example here should be pretty similar. Here we have our x's go up by 2, right? And from 2 to 10, our outputs go up by 8, right? So let's do our rate of change here. 8 divided by 2, we know that that's the same as 4 to 1, right? So that's the change in our h's, or our h of x, which is our outputs, divided by our change in x. All right. So now what we could do is we could, say, okay, well, we'll go, let's draw a table in here. And h of x. So we could say this, okay, 3 is 2. Let's see, 4 to 1, so we know that 4 is 6, right? Up 1, up 4. 5 is 10. And 6 is 11, or I'm sorry, 6 is 14, and we could keep on going until we reached 11. The problem is that would take us a long time, right? So let's see if we can reason our way through this. How far do we have to go to get from 5 to 11? Well, that's clearly plus 6, right? So if we want to change our x's by 6, right, well, how do we get from 1 to 6? That's times 6, okay? So if I go from 6 times here, I can do 6 times here as well. 4 times 6 is 24. Okay, so these are all equivalent rates of change. So now to get from 5 to 11, my inputs go up 6 and my outputs are going to go up 24, leaving me with an R equal to 10 plus 24, which is 34. All right, so that's it for the video today, and that should allow you to complete your homework problems. Thanks for watching.